factors of 18? Well, that's 9 times 2, so that's the square root of 9 times the square root of 2. Square root of 9 reduces, so this becomes 3 square roots of 2. For the square root of 125, we're looking for factors at 125. Well, that would be the square root of 25 times the square root of 5. Square root of 25 is 5, so simplest radical form is 5 square roots of 5. Over here, when I work Pythagorean theorem, I get 8 squared plus y squared equals 12 squared. 12 had to be my c because it's across from my 90-degree angle. So this is 64 plus y squared equals 144. Subtract 64 from both sides. You get y squared equals 80, and take the square root of 80. Well, square root of 80, factors of 80, square root of 16 times the square root of 5. So y is actually equal to 4 square roots of 5. So for the remaining slides, we're gonna do guided practice. I'm gonna work a problem, then I'm gonna have you work the problem. So every time I work the first problem, I want you to pause your video, and then I want you to work your second problem and then see if you got it right. So I have a triangle, and if you notice those little tick marks, that means those two sides are the same. So both of those sides are gonna be 11. And the hypotenuse is x. My c is x. So this is gonna be 11 squared plus 11 squared equals x squared. This is 121 plus 121 equals x squared. So we have 242 equals x squared. We take the square root. We need factors of 242, and we want one of the factors to be a perfect square. Well, that's going to be the square root of 121 times the square root of 2, if I look at a list of all the factors. Well, the square root of 121 is just 11. So x is going to be 11 square roots of 2. Now you pause the video and you try the second example. Now, if you check these out, do you notice a pattern between the first problem? The side lengths were 11, 11, 11 square roots of 2. And the second problem, the side lengths were 9, 9, and 9 square roots of 2. Do you notice a pattern? So in this problem, we still have the 2 tick marks, which means this is an isosceles right triangle. Both sides in this first triangle, there are going to be x now, and the hypotenuse is going to be 8. So that's x squared plus x squared equals 8 squared. That's 2x squared equals 64. Divide by 2 on both sides, we get x squared equals 32. Take the square root. Well, this is actually equal to the square root of 16 times the square root of 2. So we get 4 square roots of 2 for my x. Now you pause the video and try the other side. Do you notice a pattern? The first problem was 4 square roots of 2, 4 square roots of 2, and 8. The second problem was 5 square roots of 2, 5 square roots of 2, and 10 for the side lengths. Do you notice a pattern? Now in these triangles, if you look on both of these triangles, the shortest leg is 6 and the hypotenuse is 12. The shortest leg on this triangle is 7 and the hypotenuse is 14. If you notice, the short leg, the hypotenuse actually, let's say, is equal to 2 times the short leg. Do you see how the short leg is half the size of the hypotenuse, or the hypotenuse is double the size of the short leg? These actually are called 30, 60, 90 triangles, and we'll talk about more like why in the next upcoming days. I want to use the Pythagorean theorem on these and see if you can solve for the missing side. We'll do the first one together. 6 squared plus x squared equals 12 squared. 12 had to be the c because it's across from your 90-degree angle. So this is 36 plus x squared equals 144. Subtract 36 from both sides. X squared equals 144 minus 36, which is 108. Take the square root of both sides. And the square root of 108 is actually the square root of 36 times the square root of 3 if you look up the factors. And so x is going to be equal to 6 square roots of 3. Now pause the video and try the next one. When you look at your first question, the side lengths are 6, 6 square roots of 3, and 12. When I looked at the second question, my side lengths are 7, 7 square roots of 3, and 14. Do you see a pattern? Okay, let's try this these two triangles are both 30, 60, 90 triangles as well. Let's try these. Let's do x squared plus 15 squared equals, the hypotenuse is twice the size of the short leg squared. So we have x squared plus 225 equals 2x squared, that's 2x, times 2x. That's actually 4x squared. We're going to subtract 1x squared from both sides. We get 225 equals 3x squared. We're going to divide both sides by 3. We end up getting x squared equals 75, and then we're going to take the square root. Well, the square root of 75 is actually the square root of 25 times the square root of 3, which is 5 square roots of 3. Now pause the video and you try the next example. So go look at your side lengths. Your side lengths are now 5 square roots of 3, 15, and double that is 10 square roots of 3. And over here, your side lengths are 3 square roots of 3, 9, and double that, which is 6 squared to 3. Do you notice a pattern?